says iridium has two isotopes. Iridium 191 has an actual mass of 191.0 grams per mole, and iridium 193 has a mass of 193.0. And the iridium 191, we could look at the periodic table, and iridium is right here. Iridium, any atom of iridium has 77 protons. And whatever 191 minus 77 is, 114 neutrons. And it does happen that as you get down towards the bottom of the periodic table, you get, or let's say this, near the top of the periodic table, you tend to have very close numbers of protons and neutrons. But as you get down to the bottom, you tend to have more neutrons than protons, and you can see there's quite a few more neutrons here than protons. To get back to the problem, in any sample of iridium atoms, 37.58% will be iridium 191, and 62.42% will be iridium 193. We have no way of knowing what those numbers are. I have to give them to you, and so on a problem like this, on an exam, I would give them to you. On your conversion and equation sheets, you can see there's a formula right here for average atomic mass. We will apply this to do the average molar mass, and it says mass of isotope number 1 times its percent, plus mass of isotope 2 times its percent, plus mass of isotope 3 plus its percent. And in problems that we do in this course, there's only ever 2 or 3. But the theory, the equation is completely general. You can have more isotopes. We just usually don't. Divide by 100%. That's the formula we're going to use for this problem. So average molar mass is going to equal the mass of the first isotope, which is 191.0, times the percent. So for the iridium 191, it's 37.58. For iridium 193, the mass is 193 and 62.42% over 100%. Actually doing this math, we have 191 times 37.58 plus 193 times 62.42, and then divide that by 100%. I get 192.25 grams per mole. And if I go to iridium, I get 192.2, and the number that I calculate here and the number that I have on the periodic table should match. And in fact, you can see it's 192.248. So if I only go to 10th place, it should be 192.2 grams per mole. And these questions, so the answer to the question is always the number on the periodic table, because this is how we get the numbers on the periodic table. The numbers on the periodic table are the average molar masses averaged over all naturally occurring isotopes. So if you get a sample of iridium In nature, naturally occurring, it will have a molar mass of 192.2 grams per mole, and it will be made up of two different isotopes in these percentages. That's just how it is. And so when you get a, let's look at one in particular here. Chlorine actually is a good one. Chlorine is 35.45 grams per mole, and chlorine is actually made up of about 75% chlorine, 35, and approximately 25% chlorine, 37. If you put these numbers together, you'll get a number very close to 35.5. And again, you're averaging over all of the different atoms that are naturally occurring. So the reason I make you show your work for this one is because otherwise, calculating the average molar mass would just be the numbers on the periodic table, and it'd be the easiest question on the homework. And it's still pretty easy, I think. You just have to plug into this formula and do the math, but you will get the number on the periodic table. Are there any questions about that? Okay.